Right, so using an appropriate substitution, determine this integral here, right? We have limits from 0 to pi over 6, and the function is sine squared 3x dx. Well, whenever you see sine squared, you see we use this here substitution, which I got from the back of the exam paper, right? So we can apply this, except in our case, instead of x, we have 3x. So our function up here becomes, we keep the same limits, right? Pi over 6 on the top, 0 below, and we get a half times 1 minus cos twice whatever this x value is, right? 2 times x. Now we had 3x sitting in that position, so twice 3x is 6x dx. And we integrate that now. Well, what we can do is we can throw the half outside the integral sign, so it's, we can rewrite it like this: pi over 6, 0, and we have 1 minus cos 6x dx. Right, so that gives us a half, and we can open a square bracket here. 1 integrates to x, then we have a minus sign, write that down, right? And cos 6x integrates to, if we look up our rules, if we're unsure, right, I'm going to open up the exam paper here now, and I'm going to go down a few pages. So we had cos 6x, see that's cos ax there, right, cos ax. A for us is going to be 6, so we're going to have 1 over 6 times sine 6x. So we're going to have sine 6x over 6. And we still have to apply our limits to that. Pi over 6 and 0. Right? Now, the sine of 0, if I remember rightly, the sine of 0 is 0. Right? Which makes life easy when we're applying our limits. So we will still have our half, and we're going to have something minus something. And in the first bracket, we're going to have pi over 6 subbed in instead of x, minus sine, and 6 times pi over 6. The 6's will cancel. 6 times pi over 6, so, it'll be 6 times pi over 6, I'm going to write in there in a minute, right? So these 6's will cancel, and we're left with pi. So we get pi up here, pi, sine pi, all over 6. And in the second bracket, 0 goes in instead of x here, minus sine 6 times 0, which we've already established. The sine of 0 is 0, so it's going to be 0 over 6. So this whole second bracket comes to 0, which is handy. And then it's just a matter of figuring out this last bit. So we have a half outside of pi over 6 minus the sine of pi. Now when you see pi like that, we need to put our calculator into radians, so shift and mode 4 for radians, and I'm going to get the sine of pi radians, so get the pi symbol in there, and I get 0, which is handy. So it's going to be 0 over 6 in this position, which is 0. So this becomes a half times pi over 6, and our rules of fraction multiplication, we multiply the tops. 1 times pi is pi, and 2 times 6 is 12, and we get pi over 12, and hopefully that's the right answer. You could run that function through Desmos and see if the area between that function and the x-axis corresponds to pi over 12. So I'm just going to flick over to Desmos here, right, and here's our function in red, sine squared 3x, right. This thing is set to radians here, and these lines here, the blue line is x equals 0, these are just the limits, and x equals pi over 6 there in the purple line. And the area under the graph and above the x-axis, we got pi over 12, which is like 3 over 12-ish, which is about a quarter. And you can see that is about a quarter, because the area of this whole rectangle here is about 1/2, and it's half of a half, which is a quarter. So our answer seems to make sense. So pi over 12 seems to make sense. Anyway, that's it for that one.